American diet has changed dramatically. Near the beginning of the 20th century, Americans each ate about 120 pounds of meat annually. By 2007, that figure had exploded to no less than 222 pounds. In 1913, we ate about 40 pounds of processed sugar each per year. However, by 1999, our consumption of all refined sweeteners had risen to over 147 pounds. In 1909, Americans consumed around 294 pounds of dairy products apiece. But by 2006, our yearly intake of dairy had more than doubled to 605 pounds.
Focus more on feeding animals for their ability to be able to produce meat, milk, and eggs, protein containing. And so my own research was focused on protein, making sure we got enough. It was considered to be the vital nutrient. It was one of the first nutrients discovered. And without protein, the animal would die. So it was a life force. And in fact, in even the early 1900s, there were statements made that this is the stuff of civilization itself.
Protein was also nearly synonymous with animal-based foods like meat. It still is today, all over America.
Why do you think meat is important in our diet?
Protein.
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 A lot of protein.
We need protein, don't we? We can't live without protein.
The idea that plants had protein also didn't come into play until maybe the late 1800s, early 1900s, and then it struggled through the years.
No matter what source the protein came from, in the late 1950s, most scientists believed the world needed a lot more of it.
We had a lot of starving and malnourished children in the world. And so in my community, in the nutrition community, there were discussions about why so, what could be done. And one of the prominent thoughts was to make sure they get enough protein. I certainly want to.
By 1975, Dr. Campbell was at Cornell University, investigating what he'd discovered in the Philippines.
Our work from the beginning was designed, in a sense, to do two main things. One, I wanted to replicate, if possible, the Indian work, because it was so provocative. Secondly, if this is really true, I wanted to study how does it work.
Just like the Indian researchers, Campbell fed half the rats in his study a diet of 20% casein, the main protein in dairy products. The other half was fed only 5% casein. Over the 12 weeks of the study, the rats eating the higher protein diet had a greatly enhanced level of early liver cancer tumor growth. On the other hand, all of the rats eating only 5% protein had no evidence of cancer whatsoever. But Dr. Campbell decided to take these findings a step further. This time, instead of keeping his test rats on the same diet throughout the study, he kept them in one group and switched their diets back and forth, between 5 and 20% dairy protein, doing so at 3-week intervals. The results were astonishing. Whenever the rats were fed 20% protein, early liver tumor growth exploded. But when the same rats were given 5% protein, tumor growth actually went down.
I mean, this was so provocative, this information. We could turn on and turn off cancer growth just by adjusting the level of intake of that protein. Going from 5% to 20% is within the range of American experience. The typical studies on chemical carcinogens causing cancer are testing chemicals at levels maybe 3 or 4 orders of magnitude higher than we experience.
Even more surprisingly, Dr. Campbell discovered that a 20% diet of plant proteins from soybeans and wheat did not promote cancer. However, there's a long-standing belief among the public that animal protein is important for human health. Connie Dickman supports this position. Ms. Dickman is Director of Nutrition at Washington University in St. Louis, Missouri. She's the past president of the American Dietetic Association and an advisor to the National Dairy Council.
When you eliminate animal foods from your eating plan, you run the risk of inadequate protein content. Animal proteins provide all the amino acids that we need for cell growth, tissue repair, and overall health.
Eating whole foods, it's virtually impossible to be protein deficient without being calorie deficient, because Even if you take the foods that have the least amount of protein in it, let's say potatoes, for example, or rice, 8, 9%. That's the figure we more or less need.
Dr. Campbell's research led him to a conclusion about the way genes, chemicals, and nutrition interact to promote cancer.
Cancer starts with genes. It might be genes we're born with, it might be genes that are actually changed by a chemical. So those genes become capable of producing cancer cells. Whether we do or don't get cancer is primarily related to how we promote those cancer cells to grow over time. That's where nutrition comes into play. They go much more rapidly when they were fed animal protein.
Dr. Campbell and other nutritional scientists have found that only a small percentage of cancer cases are caused solely by genes.
I think the general consensus in my field is that probably not more than 1 or 2% at most is attributed to the genes we may or may not have.
And that's the most helpful and hopeful information I give people, because if you go through life thinking that what happens to you from a health perspective is based on your genes, you're a helpless victim.
My diet was pretty abominable. I thought the two principal food groups were caffeine and sugar.
Dr. Pam Popper is executive director of the Wellness Forum in Columbus, Ohio, and an expert in the areas of health and nutrition.
And you want?
The women in my family are all overweight. I'm not. I don't eat and live like they do. So I've changed my health destiny by not engaging in the same habits.
Over the next several years, Dr. Campbell initiated more extensive lab studies using various animal and plant nutrients. The results were consistent. Nutrients from animal foods promoted cancer growth, while nutrients from plant foods decreased cancer growth. Yet Campbell hadn't identified a specific biological mechanism that caused the effects he observed.
And it finally occurred to me that there was no such thing as the mechanism. What we were looking at was a symphony of mechanisms. We think that nutrition is attributed to individual nutrients, and that's the way it gets marketed, and that's the way the companies tell us, so forth. When in fact, nutrition, all of it working together to create this symphony, the hundreds of thousands of different kinds of chemicals in food all kind of working together nicely. I mean, the complexity is total. That's a holistic concept. And I had to say to myself, that's a very exciting idea.